Okay, now we're gonna do Beer's Law. I think I got connected. So on the phone, it shouldn't be this difficult. It has Beer's Law, and what we're gonna do measuring concentration versus absorbance. Now, just what we want to do is that you can just tell that number one is more concentrated than number two, and so this should have at the same wavelength 545. This one should have a higher density or absorbance, we call that, than this guy. Okay, and we can do that. There should be a direct relationship between concentration and absorbance. So we have three samples at 10 to the minus fifth, 20, and then 30. And then what we hope to see is that 10 may give you a value, maybe like 0.2. And then 20 you would hope to give you around 0.4. And from that we can come up with a line and see what the relationship is between the two and get a slope. And then we could use the unknown, which will be the last part of this experiment. Okay, so what I'm going to do is click on Beer's Law, and it's going to ask me to calibrate. It says calibrating, so I put the blank in. Okay, and now it's finishing up the calibration. And I have my three samples. And I'm starting with this one. Hopefully that's my 10. If it is, it doesn't matter. I just want to make sure that I get... So on here it's asking me the wavelength I want to use. I want to use 545. Okay. Right, and then it has it all set up here. And the blank is 0, and that's what we like. And so I'm going to replace the blank now with my first guy. And there it is. And so what I'm going to do is I'm going to put in $10. All right, and 10, and it says molar, but remember it's going to be 10 times 10 to the minus fifth. And there it is. I'm going to keep that point. All right, so now I'm going to set that aside. So far, so good. Okay, next one. Okay, next one is 20. And there's its value, about 0.384, which is kind of what you kind of expect, because the first one we got at 0.19, so this should be double that. Pretty close. That's good. So I'm going to keep that data, and that's 20 times 10 to the minus fifth. And then finally my last one should be around 0.6, you would hope. Okay, 0.567, which is almost 3 times the 10 value, which is really good. So I'm going to keep that value. So that's 30. And I'm done. Now I hit stop, and hopefully that'll let me save it. Okay, so okay, you see those 3 points. All right, and so I want to do some statistics with this. So I want it says curve fit. I'm going to pick linear. And then what it does, hopefully, oops, jeez, where'd you go? All right, so this is what we need to record. All right, y equals mx plus b. M is 0.01863, record that. And the intercept is 0.008483. So y is absorbance, capital A, at 545. The x is concentration, and that's 10 to the minus fifth moles per liter. And you'll be writing out that equation, and we'll go over that and on the write-up. Okay, so I'm turning this off, because next thing we're going to do is we're going to take an unknown and try to figure out its concentration based on this curve. Okay.